morning, students. Today, in this lecture number 15, we will study the laws regarding the parallel circuits. We will study the examples of parallel circuit, determine the unknown quantities in the parallel circuits. So let's start today's lecture. Now, in case of parallel circuit, there are certain laws. This law we will study one by one. So, law number 1, the total resistance of a parallel circuit is always less than that of the smallest resistance leg. This occurs because not all current flows through each leg or branch. With many branches, more current can flow from the battery. Law number 2, the voltage is the same for each leg of a parallel circuit. And the law number 3, the sum of the individual currents in each leg will equal the total current which is going from the battery. The amount of current flow through a parallel circuit may vary for each leg depending on the resistance of that leg. The current flowing through each leg results in the same voltage drop as for every leg of the circuit. Here in the diagram, you can see the 12 volt is supplied using a DC source, that is a battery. And in the system, there are two loads which are connected parallelly to this 12 volt source voltage. The first one is having the 6 ohms and second resistance is having around, you can say, it is a value here, I cannot see. It is around 2 ohms. Okay. Now, if you see in this case, the 6 amperes is flowing from the battery. From this 6 amperes, 2 amperes will be flowing through this 6 ohm resistance and 4 amperes will be moving through this 3 ohm resistance. Okay, so we have seen from this example that the current chooses the path of the least resistance. More current will flow where the resistance is less. Here, in this case, the resistance is around 3 ohms. So the current flowing here will be 4 ohms, double than this. If we sum up this current supply for each leg, that must be equal to the current from the battery. Now this is an important concept. Now take a small example. If you are driving through a car and you have two roads that will take you towards your destiny. So which road you will choose? The road with the least resistance, that is less traffic, proper road condition, less potholes on the road. That road you will choose, and the road that takes you early to your destination, or early, or you can say the road that provides you a comfortable ride, means the road with the least resistance. Similarly, in case of the current flow in the circuit also behaves in the similar fashion. It chooses the path which is having the least resistance. So this is a fundamental rule in case of this parallel circuit. Now here we have to find out the equivalent resistance of a parallel circuit. Now, as we have seen in the rules or the laws, the equivalent resistance of the parallel circuit is always less than the smallest resistance or the smallest individual resistance which is there in the circuit. Now there are certain methods. So first we will see the method number 1. The total current in amperes can be calculated first by treating each leg of a parallel circuit as a simple circuit. Each leg has its own power and a ground, and therefore the current through each leg is independent of the current of any other leg. So this is a very simple system. In this, we know what is the supply voltage for the each load. We know what is the value of resistance of that particular load. From that, we can determine what is the current which is flowing to that load by using Ohm's law. Now take this as a sample problem. I will come on this face, or I will go on this here. Okay. Now everybody can see this diagram. Now here you can see there are three loads which are connected in the parallel to the source. So we have the values of resistance for each load. Suppose I am having the supply voltage of 12 volts. I know value of 3 and 12. By this I can determine what is the current flow. Here current flow will be 12 divided by 3. It comes 4 amperes. Here the load will be 12 divided by 4, 3 amperes, and here 12 divided by 6, 2 amperes. So 2 amperes, 3 amperes, and 4 amperes. So if we sum these individual currents, it gives us value of 4 plus 3 plus 2. It is around 4 plus 3 plus 2, it is around 9 amperes. That 9 amperes will be coming from this battery, and this current is distributed among these legs as in the proportion of the load which is connected in that particular leg. Now, if we want to determine what is the, we can say, what is the equivalent resistance of these systems, so that can be found out. As we know what is the current flow, that is 9 amperes. Using Ohm's law, 12 divided by 9, it gives around 1.33 ohms. So this value of 1.33 ohms is less than the smallest resistance. Here the smallest resistance is 3 ohms. Sorry. So this equivalent resistance of a parallel circuit is less than the smallest resistance of among the individual resistances. Now here we can see that the total resistance, that is 1.33 ohms, is smaller than the smallest resistance, it is 3 ohms. These characteristics of a parallel circuit holds true as not all current flow through all resistance as they are in the series, as that in the series circuit. Because the current has alternative path to the ground through various legs of a parallel circuit. As additional legs are added in the parallel circuit, the total current from the battery also increases. Additional current can flow when the resistance are added in parallel, because each leg of a parallel circuit has its own power and ground, and the current flowing through each leg is strictly dependent on the resistance of that leg. Now we will see the method number 2 for determining the equivalent resistance in the systems. We are having the fundamental formula. RT represents the equivalent resistance of a system. It is given by product of individual resistances divided by sum of individual resistance. Here the individual resistance R1 and R2 are multiplied in the numerator, and their sum is there in the denominator. By using this formula, we can determine the equivalent resistance in a parallel circuit. Now, this formula can be used for only 2 circuits. If there are 3 circuits, we have to consider the product of we have to just see this formula is only for the I think 2 circuits. If there is a third, this formula is only for 2 resistances. If there is a third resistance in the systems, this formula can get modified, or you can get simply using the formula 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon Rn. That is, Rn represents the number of resistance in the system. Okay. Now see, this is that formula. 1 upon Rt is equal to 1 upon R1 plus 1 upon R2 and 1 upon R3, so on. Now, this method number 4. In this method number 4, this method uses an electronic calculator which is available at a very low cost. Instead of determining the lowest common denominator as in the method 3, one can use the calculator to convert a fraction into decimal equivalents. So we can use calculators or the Excel sheets to perform the tedious calculations for the complicated circuit, and using this we can determine the equivalent resistance of a parallel circuit. Now this is the next part of the previous method. Here you can see there are the individual resistance of 20 ohm, 1000 ohm and 45 ohms. So it becomes tedious to use the previous formula. Instead of that, you can use a calculator or the Excel sheets to determine the equivalent resistance. Now in this method number 5, this is another method. Here you can see there are 4 equal values of resistance which are provided in the circuit. So this from this formula we can get total resistance is equal to value of equal resistance divided by the number of equal resistance. So it gives around 12 divided by 4. It gives around 3 ohms. Okay. So in today's lecture we have seen the laws related to the parallel circuit, and we also find out the different methods by which the equivalent resistance of a parallel circuit can be determined. I hope you enjoyed the lecture, you understood the concepts. If any doubt, please feel free to drop me email. Thank you and have a good day.